Hi everyone, today we're going to go over Topic 7 Math Museum, which is all about factors and multiples. Remember, a factor is any number that you multiply to get a product, and a multiple is just skip counting. So think about multiples of 2. You could have 2, 4, 6, 8, 10, multiples of 3, 3, 6, 9, 12, 15. So anytime you see the word multiple, just think skip count. So our first question is, Courtney has 36 photos to arrange on a gallery wall. How many arrays can Courtney make with the 36 photos? List all the possible arrays. When I see arrays, I think factor pairs. So what I'm going to do first is I'm going to list out my factors here, and I'm going to write them out. So I know 1 I can use. 1 times 36 equals 36. Perfect. But remember, if I'm doing an array, I have 1 row of 36, or I have 36 rows of 1. Now, I know 36 is an even number, so definitely you can divide it by 2. Now, you can use division to help you, or you can use mental math. I know that 2 times 18 equals 36. And remember, when you're finding an array, you can have 2 rows of 18 or 18 rows of 2. That also equals 36. So that works. 3. Well, 3 I might need to use a little division here. So let me see if I could squeeze it in here. 36 divided by 3. 1 times 3 is 3. 0, bring down the 6. 2 times 3 is 6. Perfect. So 3 rows of 12 equals 36, or 12 rows of 3 equals 36. So wow, I can use 1, 2, and 3. Now, I'm going to skip count by 4 to see if I land on 36. 4, 8, 12, 16, 20, 24, 28, 32, 36. So now I know that 4 rows of 9, so nice, I use 9, equals 36, or 9 rows of 4 equal 36. I know I don't need 5 because it doesn't end in a 5 or a 0, and I know I can't use 10 because it doesn't end in a 0. So now I just have to worry about 6, 7, and 8. Well, I know 6 times 6 is 36. And I can only use that because that's a perfect square. So that's only one option for the 6. Now, 7, I can skip count by 7. 7, 14, 21, 28, 35. That doesn't work. 8, 16, 24, 32, 40. That does not work. So how many arrays can Courtney make with the 36 photos? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Courtney can make 9 arrays. And that's all you have to say for that one. Let's go to part B. How many factors are there for 36? Write them. What do you notice about the number of factors of 36 and the number of arrays Courtney can make with the photos? So I'm going to refer to part A. There's a reason why it's a part A and a part B. So I'm going to fold this so you guys can see it. I have 1, 2, 3, 4, 6, 36, 18, 12, and 9. So let's see how many factors I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. And look at that. She can make 9 arrays. I notice that 36 has 9 factors, and Courtney can make 9 arrays. Great, so part A and part B are done. Part C. Write all the factor pairs for 36. Oh, good thing I did all that work in part A. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Is 36 prime or composite? Well, prime means it only has one factor pair, and this has 5 factor pairs. So 36 is a composite number because it has 5 factor pairs. Simple, easy, right to the point. Let's move on to number 2. Determine whether the numbers in each list are factors or multiples of 16. Remember, factors is something times something equals a product, and a multiple is skip count. Okay, so 16. Well, I know 16 is a factor of 16 because 1 times 16 is 16. But now, let's see. 48 can't be a factor of 16 because you can't multiply something times 48 to get 16. So these are multiples. 1, 2, 4. Okay, well, 1 times 16 is 16. 2 times 8 is 16. And 4 times 4. So that's factors. Okay? What times 8 can be 16? 2. And 1 times 16 is 16. So that's also factors. Plus, these numbers are too small to be multiples of 16 because you have to skip count by 16. Now I'm looking at 32. 16, 32, 48, and I keep going. Let's say I don't remember, maybe I'm not good at my 16 times table, and that's okay. I can add, right? And I have 64. So now 32 and 64, I know if I skip count by 16, I will get multiples. Remember, if the number is too large to multiply, it's definitely going to be a factor. So this is all about reasoning. All right. Which statement is true? The only factors of 3 are 3 and 1. Therefore, 3 is prime. Well, I believe that, so I'm going to put a dot there because that's a maybe, okay? The only factors of 4 are 4 and 1. Therefore, 4 is prime. But what about 2 times 2? Sorry, B, you're out. The only factors of 5 are 5 and 1. Therefore, 5 is composite. Well, I know composite means more than one factor pair, so sorry, 5, you are out because 5 is a prime number. And the only factors of 8 are 8 and 1. Therefore, 8 is composite. Well, what about 2 times 4? Sorry, 8, you are also out. So this one, the answer is A. This is knowing your math vocabulary. Prime has one set of factors, or one factor pair, and composite has more than one factor pair. Okay. Determine if each number is prime or composite, then write all the factors for each number. 19 and 33. Okay, well, I can go through my list. I know 1 times 19 is 19. Okay, so that's good. 19's odd, so it's not divisible by 2. 3, 6, 9, 12, 15, 18. Oh, 3 doesn't work. 4, 8, 12, 16, 20, 24. No good. It doesn't end in 5 or 0. And I'm going to skip count by 6. 6, 12, 18. Oh, no good. 7, 7, 14, 21. Oh my goodness. I think this might be a prime number. 8, 16, 24, 9, 18. So 19 is a prime number. Now for 33, I start the process again, and I don't have to work too hard for this one, and I'm going to tell you why. Already I know something. Okay, I know 1 times 33 is 33. Okay. It's not 2, but 3 times something is 33. 3 times 11. You can stop there. As long as you know there is more than one factor pair, you're good to go. So this is a composite number. All right. Oh, our favorites. Select all equations that have a dividend that is a multiple of 4 and a quotient that is a factor of 18. You need to know your vocabulary here. So a quotient is an answer, and a dividend is something you are dividing. Okay, so select all the equations that have a dividend that is a multiple of 4 and the quotient that is a factor of 18. First thing I'm going to do, I'm going to write my multiples of 4. 16, 20, 24, 28, 32, 36, 40. And now I'm going to write my factors of 18. I know 1 times 18. I know 2 times 9. And I know 3 times 6. Those are my factors of 18. So now you're going to use this as a reference, and you're going to check. So the dividend is always going to be your first number in division equations. So is the dividend a multiple of 4? Yes, it is. Is the quotient a factor of 18? Yes, it is. So this is a yes. Okay. Is the dividend a multiple of 4? Oh my goodness, I think we need to keep going. It is. Is the quotient a factor of 18? It certainly is. Now we get to this one. Is the dividend a multiple of 4? It is not. Is the quotient a factor of 18? Yes, it is, but it didn't meet all the criteria, so you are out. 16. Is 16 a multiple of 4? It is. Is the quotient a factor of 18? It is not, so you are out. Last one. Is the dividend a multiple of 4? It is. Is the quotient a factor of 18? It is not. So your answers are this 1 and 2, A and B, however you want to treat it. All about knowing your vocabulary. Write 3 multiples, skip count, and 3 factors for 24. Okay, multiples I'm going to skip count. 24, 48. Oh, I don't know that next one. Oh no, I'm going to have to add really fast because I know skip counting is just repeated addition. 72. 1, 2, 3. I have met the criteria. And 3 factors for 24. Well, I know 1 times 24 equals 24. I know 2 times 12 is 24. And I know 3 times 8 equals 24. And I know 4 times 6 equals 24. I kind of went above and beyond here because they're only asking for 3. You could have told me 1, 2, 3, and you would have been correct, as long as you know how to factor out 24. Moving right along, write 2 multiples of 3 that have a factor of 7. Multiples is skip count. Factor is something times something equals product. So write 2 multiples of 3 that have a factor of 7. You've got to write out all the multiples of 3. So let's write them out. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, I'm going to keep going. 33, 36, 39, 42. Write 2 multiples of 3 that have a factor of 7. So now I'm going to write out my 7 times table. 7, 14, 21. Ooh, they match. 28, 35, 42. Oh, they match too. Now, I know we're not usually comfortable going past 30, but sometimes you have to get the right answer, okay? So 2 multiples of 3 that have a factor of 7. I know 7 times 3 is 21, and I know 7 times 6 is 42. And look, 21, if you just double 21, you get 42. Just saying. Ooh, select all the true statements. Another one. Here we go. 33 has more than 2 factors. Well, it certainly does. We have 1 times 33 and 3 times 11. So that is true. All of the factors of 34 are even numbers. Well, 1 times 34? Well, 1 is an odd number. So, disagree. 35 has exactly 2 factors. 1 times 35, 5 times 7. Incorrect. 3 is a factor of 36. Well, I know 3 times 12 is 36. So that is correct. 37 is a prime number. So now I have to think what times what is 37. So I have to go through all of my skip counting. So let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know I can use 1. I cannot use 2. I cannot use 5, and I cannot use 10. It's not even, and it doesn't end in 5 or 0. So now I have to think, do any of these numbers work? Well, I just said 3 times 12 is 36, so can't use 3. I know 4 times 9 is 36. I can't use 4. 6 times 6 is 36. Can't use that. 7 times 5 is 35. It's looking like a prime number, but let's keep going. 8 times 4 is 32, and 9 times 4 is 36. So yes, 37 is a prime number. You can only do 1 times 37. 38 is a composite number. It's even, so that is true. You have 1 times 38, okay? And then if I divided by 2, I would get 19. 2 times 19 is 38. So yes, 38 is a composite number. Okay. Martika says factors and multiples are related. Use the equation 6 times 7 to describe the relationship between factors and multiples. Well, 6 times 7 equals 42. So I know a factor times a factor equals a product. Okay? So now 42 is a multiple. So let's do multiples of 42. We have 42, 84, and then, oh, maybe I'm not sure. I'm going to check anyway. Okay, it's 126. So a factor times a factor equals a product, and we know that in order to get a product is a multiple. So 42, 84, 126, you can use these numbers to find these multiples. So a product, so you can say a factor times a factor equals a product, and a product is a multiple of an answer to a multiplication equation. Okay. Which lists all the factors of 25 that are prime. So it's looking for two things here. You're looking to factor out 25, but also just prime numbers. So 1 times 25 and 5 times 5 are our factors for 25. But 25 is composite. 1 and 5 are prime. So A is incorrect. 5 is a maybe. 1, 10, 25. Well, 10 isn't a factor of 25, so that's immediately wrong. And I remembered that 25 is a composite number. So the answer to that is B. Knowing your vocabulary, that's all that one is. Okay. Carter lives on a street where all the house numbers are multiples of 6. Name 2 possible house numbers between 70 and 80. Explain. All you have to do is skip count by 6 till you get between 70 and 80 and give me 2 possible numbers. 6, 12, 24, 30, 36, 42, 48, 54, 60. Now you may have to start counting on. 66, 72. Ooh, here we go. We're in between now. 72, 78, 84. So our 2 possible numbers are 72 and 78. I skip counted by 6 to get my answer. That's all. Not too hard. All right. We're almost done, everyone. Okay. Write the factors of 30 that are also prime numbers. Here comes that vocabulary again. I know 1 times 30 equals 30. I know 2 times 15 equals 30. Okay. I know 3 times 10 equals 30. And I know 5 times 6 equals 30. So now you have to circle all of the prime numbers. Be careful. 1 is neither prime nor composite, so don't let that trick you. I know 3 is a prime number. I know 2 is a prime number. And I know 5. So factors that are also prime. Two, 3, and 5. 1 is the unicorn. It is neither. Last question. Javier says all odd numbers greater than 2 and less than 20 are prime. Find an odd number greater than 2 and less than 20 that is not prime. Explain why the number is not prime. So explain why it is composite. So let's list out all of the odd numbers greater than 2 and less than 20. 3, 5, 7, 9, 11, 13, 15, 17, 19. Find an odd number greater than 2 and less than 20 that is not prime. Well, 3 is prime, 5, 7, there it is. 9. 9 is composite because it has more than one factor pair. You could even prove it. 1 times 9, 3 times 3. 15 is also an excellent option. 1 times 15 and 3 times 5. Okay, that's everything, everybody. Remember to go over your vocabulary, prime numbers, composite numbers, factors, multiples. Practice your skip counting, and you will be good to go for the assessment.